Hello and welcome to the Monash Tech Talk. I'm Bernadette Schwerdt and I'll be your host and facilitator for this event. And what an event we have for you. It's a veritable cornucopia of content for you to feast upon. Now, it's no secret that AI is changing the world in which we live. It's innovating, it's transforming our business and our world on a scale like never before. We have a stellar lineup of speakers for you today, and each one of them has got their finger on the pulse on a very specific aspect of AI. And they're going to share with you their unique insights and wisdom and knowledge so that you can take that information, you can go back to your office, your business, your world, and implement some of those learnings so that you can take advantage of the massive opportunities that AI is presenting to us now and in the future. Now, speaking of the future, I'm just curious, and I'd love you to just put into the chat box, yes or no. Has anyone here seen the film Inception, starring Leonardo DiCaprio? So just take a moment to put it in and we'll see what kind of cohort we have got running here today. Okay. Wow, okay. Interesting. Now, here's our second question. How many of you who've seen the film understood Inception? Because I can tell you for a fact, I've seen it 3 times and I still don't know what's happening. And in fact, I said to my husband every time we watch it, what level are we in now? And, you know, the reason I'm saying this is because that I was talking to a friend of mine and I was trying to explain the film Inception and I couldn't remember the title. And I Googled it and I put in the movie about layers of dreams. And do you know what the first result Google came back with? Inception. So my answer, well, my question here is, was that multimodal AI at work or was it your garden variety AI at work? Because there was no keyword in sight. Very interesting. It inferred what I was looking for. So I'd like to welcome you all. Thank you very much for coming along. And I'd like to kick off by acknowledging the traditional owners of the land on which we meet today and pay my respects to the elders, both past, present and emerging. Now, you're not here to hear me speak. You're here to hear our experts speak. But I thought I'd give you a quick overview of why I'm here in my context and what I think, why I think Monash invited me to be the MC. My background, very briefly, is I've got 30 years in marketing and advertising, working with global brands like Apple and Amex and Colgate. And in my last 20 years, I've run the Australian School of Copywriting. And what we do is we teach people how to use search engine optimization copywriting to get found and be on page 1 of Google. Now, with voice search coming along, that's a game changer that I am personally very interested in. And the entire advertising industry is very interested in, because no longer will we have this list. You know, businesses are going to be found in a very different way. And as a non-tech founder and not being a technologist, I often say to my technology team, how's that good for business? You know, what problem are we solving? How can we communicate this in a way that's understandable? And I think that's my role today, is to be the bridge potentially between these amazing speakers and the business community as well. But I'm sure they'll be doing that quite fine on their own. So first up, our first speaker will be Associate Professor Reza Haffari. And Reza is the lead in the Vision and Language Group within the Faculty of Information Technology at Monash University. He is a world-leading researcher in natural language processing. He's been invited to speak at major events for companies such as Facebook, Amazon, and Google. And his group are driving state-of-the-art projects in the areas of machine translation, reasoning, question answering, explainable AI, smart insurance, and more. Our second speaker is Professor Joanna Batstone. And Joanna is a global expert on AI, data analytics, and technology. She's the inaugural director of the Monash Data Futures Institute at Monash Uni, which supports government and companies to use AI and data to help with the COVID recovery and develop policy for social good. She's responsible for data science and AI across the university. And prior to this role, had a leadership position with IBM Watson. And our third and final speaker is Dr. Michelle Ananda-Rajah. Now, Michelle is a consultant physician of general medicine and infectious diseases at Alfred Health. Her research interests include AI, health services research, and the occupational safety of healthcare workers. She's the founder of Fungal AI, a platform developed with Monash that aims to facilitate faster surveillance and diagnosis of fungal infections in haematology patients. And in 2019, she was awarded a prestigious TRIP Fellowship by the Medical Research Future Fund. And during the COVID-19 pandemic, she appeared on Q&A and became a leading advocate for Australian healthcare workers. So please join me in giving them all a rapturous virtual welcome. So, Reza, let's begin with you. So this entire event is dedicated to multimodal AI. So what is multimodal AI and why is this relevant to us right now?
Yes, I want to say hi to everyone. It's a pleasure to be here and to talk about multimodal AI with all of you. So to answer the question, one of the goals of AI is to reach human level intelligence. But let's look at some of the defining features of human intelligence. So the first is the ability to make sense of multiple perception types, namely visual, verbal, and vocal. Let's refer to them as the 3 Vs. This is desired for showing intelligence in a diverse set of situations, similar to what we as humans do. And this is what is referred to in the community as artificial general intelligence. So the second defining feature is the ability to interact with the environment and take actions, perhaps to achieve a certain goal or just to have fun. This requires the capability of what we call high-level reasoning. And the third is the ability to take actions with minimal or no human involvement and supervision, which in new situations encountered by the system. And this is touching on the autonomy aspect of the definition. So by autonomous multimodal AI, we mean intelligent agents which can interact with their environment purposefully through multiple senses and with minimal or no human supervision.
Okay, great description. So Reza, can you give us an example of some of the projects you're working on at the moment with multimodal AI?
Yeah, so one of the projects is we are working on a mental health chatbot where the system interacts with the human to kind of coach the human and understand the human and kind of try to make a connection through language and the visual features of the human to be able to kind of give advice to the human. So that's one of the examples of a multimodal AI system that we're working on.
Okay, so Reza, you've done some work in the car industry in terms of the autonomous car. Can you talk to us about some of the developments that we're seeing there?
I myself haven't worked on autonomous cars. My colleagues will talk about it more, especially Joanna, we will talk about it more. But I can mention a few things about our group in Monash, if that's okay. So I'm part of the Department of the Data Science and Artificial Intelligence in Monash University. And I'm actually the director of the Vision and Language Group, where our goal is to take steps toward human-level intelligence by pushing the boundaries of the current state of the art on different fronts, particularly multimodality, which is the main subject of today's discussion, and how to make sense of multiple senses holistically to better understand the agent's environment. So this is what we are working on in the group, and our mission is. I have to mention that the intelligent agent that we are talking about here can be like a physical robot with the hardware, which is probably what people usually think about, or it can be like software bots, which for example, the personal intelligent assistants like Google Now and Siri, they belong to this category. So whenever we say agent, we mean we mean a general meaning of it. So I can summarize the goal of our group as low-level multimodal perception and high-level reasoning research to enable these capabilities in intelligent agents.
Okay, so when you talk about the voice assistants, I think we all use, Siri or Alexa or one of those. What are some of the developments you're seeing there? I mean, I talked earlier about voice search and the way that's going to transform the way in which we look for, businesses and how businesses show up on Google. Can you talk to us a little bit about some of the developments in that?
Yeah, so some of the developments that we have basically are related to the complexity of finding the semantics of human language. So many of these systems are good for very controlled situations where the human utterance basically aligns with a particular format that the system expects to understand. But when you go to very free format for utterances, the system has difficulty to understand it. And one of our goals is to make the understanding and semantics of informal, very, very informal human utterances possible for these intelligent assistants.
And in terms of how industry what sort of lessons do you think industry need to take away from these changes in the way that, voice search, for example, or this natural language processing is going on? What do we need to think about?
Yeah, so the industry is driven by revenue, right? So they want to engage as many users as possible to increase the revenue. So some of these goals, like revenue based goals, are low-hanging fruit. So you can reach it with few hacks, or what I don't want to call them hacks, but essentially they are hacks. But I'm not saying that these are all hacks, but there are really good work there as well. But there is a long distance to human level intelligence, and we are not there yet by any measure. So one of the lessons that I would say is that the human level intelligence is, reaching to that level is really, really hard, and it requires long-term research instead of working on low-hanging fruit type research in short term. And I think this is one of the lessons that we've learned.
So I might move the conversation on to Joanna. So thank you, Reza. Fabulous work that you're doing, incredibly complex. And I think we're all very grateful for the attention you're bringing to this and keeping Australia and Monash and everybody up to speed with what we're doing in a very difficult environment. So thank you. So Joanna, over to you. Now I have a question because you have a background at IBM, Big Blue, and also Watson, which I think everyone's interested in. In fact, I just watched the episode of Watson and Jeopardy in 2011 when Watson beat, the Jeopardy world champion. And I think that was the defining moment in AI about, wow, what's possible. So maybe you can talk to us a little bit about your background at IBM and what you did with the Watson project.
Yes, thanks, Bernadette. It's great to be here today. So what is Watson? It's sort of a play on the answer to a Jeopardy question, right? And so back in 2011, I was in IBM research in Yorktown Heights as part of the bigger organization that was building what we came to know as the Watson Jeopardy computer. And so for those of you who ever watch it on TV, as you just did, Bernadette, we built an entire production studio within our Yorktown Heights research auditorium in order to host that Jeopardy production. But when you think about Watson at the time, 10 years ago, and you think about the game of Jeopardy, that was really, in essence, one API, question and answer. And it was really around natural language processing, textual analysis of masses of documentation and content. And so if you think about 10 years ago, a single set of APIs that became the genesis of the business for IBM around Watson where Watson became and where Watson is today is very much a multimodal set of assets, capabilities, APIs. Reza mentioned the 3 V's around visual, verbal, and vocal. I often think about the 5 senses, right? Speech, touch, the spoken word, the translation, the listening capabilities, those human senses. The AI capabilities today have to evolve to the point where we have more of those human characteristics. So Watson today, the AI business within IBM today, is very much focused on driving business transformation around using those 5 senses: speech, language, sight, auditory, perhaps not taste, although we did have some experiments around Chef Watson in predicting cocktails and interesting food combinations. But it's very much around how do you take those fundamental API building blocks and now build industry solutions, to Reza's point, that ultimately are going to transform business, drive profitability, drive growth, and make a difference.
Great answer. So, Joanna, in your role as the director of the Monash Data Futures Institute, can you tell us a bit some about the problems you're solving and in terms of how industry, well, there's 2 questions there. Firstly, let's talk about the problems you're solving. What are some of the projects that excite you that you're working on there?
So I joined Monash late last year in the middle of this pandemic that we've been living through. And within the Monash Data Futures Institute, we have 3 primary focus areas. One is around AI for health sciences, and we'll hear more of that from Michelle later. Another is around AI for sustainable development, right? How do we use data science and AI to accelerate our progress towards the United Nations Sustainable Development Goals? And then the third priority focus area is around better governance and policy. And so by what I might mean by that is thinking through the kinds of questions that society has around our trust and acceptance of AI technologies. How do we feel about autonomous agents, as Reza was mentioning, all of these bots and agents? What are some of the societal implications, ethics, regulatory frameworks that are involved? And so those 3 thematic areas are the areas of work within the Institute. If I think about what we've really accomplished over the last 6+ months, we've been living through a world within the city of Melbourne, the greater city of Melbourne, and we see cities around the world living through this global pandemic. And so one of the landmark pieces of work that we've been doing from a data science and AI perspective is around a program that we put together called the Melbourne Experiment, which in essence was an analysis of life before, during, and hopefully after the COVID-19 pandemic, and the experiences of people in the city of Melbourne during the first lockdown, the second lockdown, and the third lockdown. And so it's a big experiment. It's the Melbourne Experiment. It's about analyzing data, analyzing the perception of people's experiences during lockdown, analyzing social media data, visual analytics data, pictures on Instagram, all kinds of social media information, but then integrated in with other forms of experience, transportation data. Are we on the trams? Are we on the trains? Looking at IP traffic data. And so this whole notion of multimodal means that we have to be able to bring together different experiences, different sources of data, text, vision, auditory, information that's coming off systems, system logs, IT system information, and integrate it together, but drive new insights. And because of the volumes of data, you have to use AI. You have to be able to develop new algorithms, new approaches to data management, data ingestion. But that's one of the pieces of work we've been doing recently, is this whole notion of the experience, both with aged care providers, with transportation providers, around how do you transform life in the city after a pandemic based on the experiences of monitoring and measuring the data during the last 9 to 12 months that we've experienced.
Wow, massive project there, Joanna. Where are you at with that research project? I mean, are there any results coming through, any learnings so far?
Yeah, so we can point you to some of the findings. We've got a nice website that describes many of the projects. But for example, some of the findings that we've been seeing is really looking at impact of things associated with, for example, are we filling our prescriptions in the middle of a pandemic? What is the impact on domestic violence during a pandemic? And what does the data show around, in fact, an increase in domestic violence during a pandemic? The data associated with transportation, particularly interesting in terms of our willingness to take the train into the Melbourne CBD. And as we slowly transition back to work in the office and back to work on campus, how do those trends in people's willingness to take public transport change? And how is it different in Melbourne compared to other cities around the world? And so those are some of the things that we're really exploring that have a tremendous amount of insight. And of course, identify the need for AI in the first place because the volumes of data are just so enormous.
Yeah. Now, one question I have, Joanna, about what you're just talking about is, how is this data being collected?
So a lot of the data with the City of Melbourne is collected and shared through the City of Melbourne. It's accessible through partners to a number of different partners. Within Monash ourselves, we've been collecting data within the precinct of Monash. One of the interesting things about Monash is that we can instrument our own precinct and also measure data and collect data from systems and buildings and transport networks. But I think the point about data is really important here. We spend a lot of time talking about AI, but AI is really only as good as the data that we can use to process. And so it leads into one of the other questions I think you have around, how do we drive more impact with AI? And ultimately, one of the risks of adoption of AI is that we actually don't have enough of a strategy or an information governance approach around how we manage data, store data, curate data. And that's often one of the pitfalls for industry to adopt AI projects and put them into production, is it actually requires you to have a pretty robust enterprise information architecture in order to be successful with the implementation of an AI project.
Oh, Joanna, this is really interesting. I'm curious as to who is the managing body for the ethics around AI. I mean,
yeah, so it's interesting. And again, if you look around the world, what you'll see is, for example, the European Union have just announced some frameworks and regulations around AI. The government of Indonesia has an Indonesian government regulation framework around AI. Within Australia, we had, over the last couple of years, a series of consultations with a lot of university consultation around what should future regulations around Australian ethics and Australian AI look like. And the Australian government has published some very interesting papers that enable us to lay out a framework around ethics and AI governance. And then within the states as well, the individual states have recommendations and policy frameworks around AI. Here locally in Melbourne, the Committee for Melbourne published a white paper back in December, again, with a lot of consultation from industry partners, perhaps some of the audience today, providing consultation into the City of Melbourne around the future of AI from an economic development perspective, jobs of the future, and what do we need to be able to take advantage of these new technologies, and what are the skills that we need to enable in our community as well in order to reap some of those economic benefits that we all hope for.
So Joanna, this might be a difficult question to answer, but do you think the technology is getting ahead of the governance? And what are the consequences if it is?
So I wouldn't say it's the technology is getting ahead of the governance. What I would say is that as the technology becomes good enough to be able to accomplish the things that we're seeing in flight today, it drives the conversation around governance and policy that we need. And it moves perhaps a more academic discussion around ethics into the much more practical aspects of what does it mean to have informed consent within a doctor's office, and what are the ethics associated with, for example, using AI-assisted diagnostic tools within the doctor's office. So I think it's not so much that the technology is getting ahead, but it's that the technology is enabling us to have the conversation around governance that we need to, because the technology is now good enough and it's no longer science fiction. It's actually good enough to start putting into real business examples and production use cases.
Well, that's a lovely segue into what recommendations would you give to businesses listening today in terms of how they can adopt or leverage some of the technology that we've been talking about? What are the lessons they can learn from this?
So as I look at, certainly primarily from my own industry experience of trying to deploy successful AI implementations and projects, I think there are really 3 lessons learned or 3 experiences that are really important. One, we've touched on briefly, data. Lots of companies are experimenting with AI proof of concepts. There are thousands and thousands of proof of concepts that companies have tried. Trying to get your proof of concept into production means you actually, and for you as a startup founder, I'm sure you're aware of this, you've got to be looking at what are the business outcomes I'm looking for. It's not about playing with technology. It's about, am I trying to accomplish revenue growth? Am I trying to improve my profit margins? Am I trying to drive new client acquisition? Am I trying to stop the erosion of client loss? Am I trying to identify new businesses to go after? Am I trying to minimize the cost of IT outages? The AI project has to tie to a business imperative and outcome. Otherwise, it becomes a proof of concept experiment in a lab. And the other thing is skills and trust, right? Some of the impediments are, how do we find the workforce of the future? There's a war on talent for people with the right AI skills. And so for businesses to be able to run and manage production AI implementations, business has to have access to the talent and the workforce of the future. So those are some of the key observations of characteristics for success, but also some of the pitfalls. Understanding my data, do I have the right skills? And can I trust my AI system?
Fantastic, Joanna. I think you've really nailed it. I mean, businesses are all about reducing cost, reducing risk, increasing revenue. So the mission, the message I'm taking is if you can connect your AI project to that, you've got a decent chance at getting it up, the POC anyway. So thank you. Fabulous. Really amazing work that you're doing.
Great.
I'd like to turn our attention to Michelle. Now, Michelle, you're doing some interesting work on a different level altogether. It's more about the health, and you've been absolutely instrumental in the advocacy for healthcare workers during the pandemic. So maybe you can talk to us firstly about, what you're doing. What is this Fungal AI platform? What's that about? We're really interested in that.
So thanks for having me. It's really nice to not talk about COVID for a change, or hotel quarantine or vaccines. I'm actually coming back to something that I've had an interest in for many years. So what is Fungal AI? So Fungal AI is essentially a multimodal platform which uses text and image classification on chest imaging, particularly chest CT scans, which is a particular type of imaging modality, in order to detect and diagnose fungal infections. So, people might say, well, what's a fungal infection? Well, everyone's heard of bacterial infections. Everyone's heard of viral infections, overheard. And then there are fungal infections. And fungi are actually, they're neither plants nor animals. They have their own kingdom. And fungi are ubiquitous everywhere, in the soil, in the water, in the air we breathe. And what fungi do is in a normal host, like you and I, no major health issues, we breathe these spores in, we breathe them out, no problem. Or the cells in our lungs particularly just pick them up and get rid of them. But if you do have a weakened immune system due to cancer, chemotherapy, or transplantation, and that actually affects, I would say, around 24% of the Australian population. So that's a huge number. 4% of the Australian population is immunocompromised, severely immunocompromised, meaning they have HIV, transplantation, blood cancers, that kind of thing. And then another 20% are on other types of medications, for example, that would also lead to immunocompromise, like corticosteroids, prednisone, taken for asthma, for example, or biologic therapies that might be taken for rheumatoid arthritis. So these patients are on a spectrum of risk. And the people on the highest risk are the ones who tend to get fungal infections. So particularly patients with blood cancers, because they are the most impaired out of everyone. So the idea with Fungal AI was to basically detect and diagnose fungal infections quickly, because the faster you do things in medicine, the better the outcomes. That's obvious. But detection, when I talk about detection, I'm talking about surveillance, all right? This ability to surveil an entire organization or a network, for example, and pick up these rare diseases in order to improve research or hospital quality improvement programs. So the kinds of quality improvement programs that are important in hospitals are things like antifungal drug management programs. We call that stewardship. You might have heard about it. Antimicrobial stewardship is like a national standard in this country. It's mandated by the WHO and by our own Australian authorities. So all hospitals have to basically monitor their drug use. And as for antifungal drugs, they're actually not monitored that well. And it's kind of surprising, mainly because, you know, they're expensive. So these are niche drugs. One particular agent costs $2,000 a day. So if you use that for 10 days, that's like someone's salary, right?
Wow.
And the hospital I work at the Alfred, we spend somewhere in the order of $4 to $5 million a year on antifungal drugs alone. And yet we're unable to tell in, you know, a timely fashion how those drugs are being used and what the outcomes are. And one key outcome of that sort of management program called stewardship is, well, how many fungal infections are you getting? Who's getting them? What are their outcomes? Okay, it sounds like completely obvious data, and yet it's difficult to extract this data from hospitals. And that's mainly because these infections appear as an unusual feature in the lungs. Often you don't grow them because the patients might be too sick to have a particular type of test. And so you're relying essentially on a radiologist giving you an opinion. The other kinds of programs are things like infection control. So, you know, you would have heard of outbreaks occurring in hospitals. So these occur, I would say sporadically. They're not common, but they certainly have been well documented, both in children's cancer centers and adult cancer centers. And it's often related to basically bad water management. So, you know, you might get water leaking through the roof. You get a bit of mold growing somewhere, and then it starts to contaminate the environment. And then patients with leukemia or whatever transplant, they get these infections. And the rule of thumb is that they're always picked up late. So, you know, these are just two kinds of scenarios. And then there are, I mean, it's important for radiologists to be able to identify these infections early. And that's mainly because they're unusual and they're rare. And so it's easy to miss these things. So those are just three kinds of contexts that we're using this software in.
Yeah, well said, Michelle. What are some of the barriers you're finding in terms of getting this technology to the next level?
Yeah, so I always think about AI in terms of three kind of steps, if you like. And this has been really nicely laid out by Enrico Coiera in a paper. It was beautifully written. It was called, I think, The Last Mile of AI. If there are any students here, you should read it. Very simple, but beautifully conceptualized. And he talks about data, he talks about model building, and then finally implementation. So we are fortunately in the last mile now, which is implementation. But having gone through the first mile and the middle mile, I can say that, you know, it was really hard, particularly because this is AI, which is being designed for scenarios where data is scarce. Okay, so fungal infections are rare. There are no publicly available data sets. And so we basically had to build the picks and chisels in order to find these infections. And then we developed a corpus of labeled data. We use natural language processing to do that. That was in collaboration with Reza. And now that we have a corpus, we're able to pull out the images and now build an image classifier. But along the way, so that's just the data, right? The data side, the kind of getting the high quality labeled data. But there's not much of it. So that's the key, right? Rare diseases do not have high volumes of data ever. And then the second issue, of course, came down to training. So, you know, it's one thing to have labeled data, but then how do you train? And, you know, the kind of challenges we went through was really around, well, how do we iron out the variation between radiologists in labeling images? And that was a really instructive process to go through. It was slightly excruciating, I've got to say. I mean, the hours I have spent with a room full of 3 radiologists who just cannot agree, right? So
what were you disagreeing about, just out of interest?
Well, I mean, you know, it was really hard. We did all kinds of things. It was, we had to basically get them to come up with, we came up with a consensus guideline, pre-specified guidelines on what we were going to label, because the imaging features are not, they're not uniform. Nothing in medicine is uniform, right? So we really had to come up with, some pretty core guidelines on, all right, guys, this is what we're going to be labeling, because this is what we want our machine to do. And you would think that on paper that would be simple, but the thing was, they all just label different things, and then we would bring them back and say, okay, well, why did you do this? Why did you label that? And it was all over the shop. But it kind of demonstrates how I think it's challenging to develop AI, because this is a black box, but the biggest black box is actually it's up here. You try and get us to unpack our thinking, and it's again, huge amount of variation. We almost can't even do it. We can't even explain why we arrive at certain decisions. So I find it fascinating when we talk about explainability in AI, that we're trying to open up that hood, right, and peer inside. And gosh, it's challenging.
It's dark, yeah. So, Michelle, I'm interested, Joanna talked about the skills as well, about the kind of skills that we need to be developing in industry. What do you see as some of the skills that should be focused on, particularly with the students listening in a Monash University presentation?
Yeah, so Monash has amazing, just incredible capability. And we are so lucky I'm lucky actually that I met Reza and a few other people in Monash, and the infrastructure is there. So one thing is, I will say you need to invest. An organization needs to invest in infrastructure, right, in order to do AI. So that is kind of the fertile ground, right? And we do have that. We have unbelievable capability in e-research with respect to, things that we're using have never been used in Australia. Things like the secure e-research platform, which is essentially a safe haven. And, data is parked in there. Students and researchers and whatever can play with that data. They can do their experiments without that data ever leaving. That is actually, for a clinician like me who's time poor, to know that I've got people who are working on the data with that data being secure is phenomenal, right? So we have things like that. We've got access to Massive, we've got access to RDS, we've got access to cloud compute, and so on and so forth. And we've got amazing governance of that data as well. It's tight. So that's the first thing. But in terms of the skills, I would say students should really look beyond just the data and the training and the theory behind that. I think that's really interesting and it's really important. But the next step is actually implementation and integration, particularly in healthcare. And healthcare, I've got to say, I don't think it's exceptional to say this, but it is probably one of the most challenging environments to integrate AI into.
Tell me why. What is that?
Because you've got human and organizational factors to deal with. And human factors, you think that there wouldn't be that much variation, but there is. And organizational factors are very unique to the organization. So, for example, for me, I've integrated Fungal AI at the Alfred. It's up and running. We're using it for a particular use case. But having, just completed a multi-center study where we've basically acquired data from 7 hospitals around Australia and Singapore, we've just finished that like end of last month. That was challenging, right? It took me, I had to fly around the country pre-COVID, of course, and basically meet and greet, and in order to get build that trust relationships and get that data. So integration is actually something that is challenging, and I think that Monash and universities in general need to build much closer industry partnerships in order to understand how to implement in the real world. And we're learning. And I think, this also speaks to what Joanna said, which was that, sometimes you need to have the user case, right? The use case to do that. And it just makes it much more relevant. If you can go to a hospital and say, look, I've got this algorithm, I think it can help you, and we'd like to implement it. I think that's absolutely the way to go, rather than, to kind of make it a theoretical thing. You've got to make it practical.
Yeah. Michelle, amazing work that you're doing, and congratulations on the achievements, because it's not easy what you're doing. But I'm going to just finish with you with one question, if I can, before we open up to the group. If you had a magic wand, because you talked about things you'd like to see happen, I'd love to know what they are. Like, let's just say budget, staff, talent, time was at your disposal. What would you like to see happen?
Wow, that's like a kind of a laundry list. Well, I would love to see, I would love to see leadership at a national level in AI. I had the privilege, I think it was last year, of being on a grant review panel for AI, and it was oversubscribed, and for a relatively small amount of money. And I was really conflicted because there were some absolutely phenomenal projects and they just weren't going to get up. And I think that's a shame, right? So I would like to see, obviously, I want to see more funding directed to the sector to really, cultivate our capability. I'd like to see industry and academic partnerships fostered. And I'd like us to take a more entrepreneurial outlook so that we can actually think about AI in terms of, how do we actually improve? How do we use it for social good or for good in healthcare, et cetera, et cetera? So that would be my wish list.
Awesome. What a great starting point. So thank you, Michelle and Joanna and Reza. Fantastic responses to a complicated topic. I'd like to turn our attention to the questions from the audience. And what would you say about the current state of reinforcement learning? So I'm not sure if that got that question in time there, Jean, for me to find out who that might be, but who would like to take that question in the absence of any direction?
I can take
Thank you,
that.
Reza. Thank you.
So I think reinforcement learning has progressed a lot due to the integration of the classical algorithms with the recent advances in deep learning. However, there is a long way to go in the sense that currently reinforcement learning is good when the problem is well defined. We have a very good idea about what are the agents in the environment, what are the possible actions, and we can kind of model the dynamics of the world very well as well. But the real world is full of uncertainties and full of non-well-defined things that we cannot model. But somehow human can find their ways of navigating this very complex and dynamic world and deal with those situations. And one example of it is natural language, where although we can write grammars and everything, but there are nuances like metaphor and etc. In natural language, which makes the understanding of it very difficult for machines, because we cannot kind of well define those things for machines to understand it. To kind of understand whether a sentence is funny, you may need the word knowledge or background knowledge to infer that. So somehow humans are able to do that, but the machines cannot. And this is exactly where I think there is a big gap between human intelligence and the current research in deep reinforcement learning. So deep reinforcement learning, to summarize, is good in a very controlled, well-defined environment, whereas to be able to act intelligently in the world as we know it, there are a lot of complexities and uncertainties that are currently we are very far away from understanding them very well.
Yeah, excellent, Reza. In fact, a question came through earlier that I might direct at you as well, because it came through while you were speaking. From Mark, the idea of AI attaining human-level intelligence keeps getting mentioned. What do you mean by this, and what assumptions are you making about intelligence? Some difficult questions unanswered about human intelligence include the role of A, moral development and moral psychology, and B, emotions, and C, consciousness. Please discuss in about 3 minutes.
All right. So the classical kind of way of measuring intelligence is by the Turing test, right? So you have a machine and you interact with it. I mean, you interact with a black box. You don't know whether there's a human or a machine. And then if you see intelligible communication with that thing, you call that intelligent. So that's very hand wavy kind of way of defining intelligence, and So that's what people use to kind of evaluate their models and the progress as well in the field. But of course, it's very simplistic. There are a lot of other elements into this as well. Like, for example, perception is a big part of being intelligent. Like, being able to kind of transform or convert the kind of dirty sensory input, like, in the vision, in the touch, in the speech signal, in the voice, to kind of clean and workable knowledge. This is non-trivial, but the pioneers of AI thought that, okay, this can be done, but the main problem is with the reasoning. But it turns out that, it is not that trivial.
Not trivial at all.
Can I say something? Can I add something to that?
Michelle.
I mean, I think when I think of intelligence, I think of your ability to problem solve, right? And that actually takes soft skills and hard skills. So it's not just knowledge. And a machine would be amazing at being able to digest information and spit out probably pretty credible answers, but it's also those soft skills. And I don't know how a machine would ever learn those. I mean, maybe it will one day, but that's something that requires, teamwork, collaboration, conflict resolution, all those sorts of things. And, so maybe we're asking too much of AI. I'm satisfied with AI that acts as a tool that's assistive in some way or augments my decision-making. Do I really want it to be smarter than me? I don't know that I'm entirely comfortable with that. I'm quite happy to keep it on a leash.
What about you, Joanna? What are your thoughts on that?
Right, with this whole notion of human intelligence, I think the perception discussion that Reza raised and this sort of experiential side of human intelligence is very hard for computers. And from a computer science perspective, people would say, well, look, we're good at supervised learning today, right? We can teach computers to do specific, somewhat narrow tasks from an AI perspective. But this notion of general human intelligence is much harder to come by. And so, I think today we're in this realm of very specialized AI solutions for special purpose tasks, whether it's for Fungal AI with Michelle, whether it's with playing chess or the game of Go. But at the moment, we can teach our AI systems to be really excellent and probably at human level expertise, or even greater than human level expertise at very specific, well-defined tasks. This broader set of general artificial intelligence, I think we're a long way off. And that's where some of these other characteristics of reasoning and perception come in. I mean, if you think about a picture, all of us are sitting here with backgrounds behind us. If we were to give a picture or a photograph of our backgrounds to a computer and ask a computer algorithm that's been trained on recognizing medical images, or a computer algorithm that's been trained on recognizing cats and dogs in Instagram photographs, the algorithms may do a pretty decent job of saying, okay, I've got 3 people in these Zoom windows. I've got plants behind Michelle and Bernadette and Reza, and maybe trees behind Joanna. But each one of us as a human is going to look at the picture and articulate a very rich set of descriptive characteristics about the picture with no prior knowledge of what we would all look like. And that notion of what can computers do today versus what does the human brain enable us to do is just very, very different. But AI systems today, I think, can be really good and perhaps exceed our capabilities in these very narrow use cases.
Yeah, well said, Joanna. I've got a question from Justin that's kind of touched on, but I might just ask Reza, your response to this. Is probably an obvious question, but I'd be interested to hear the speaker's estimate on when or if we will achieve human level AI. Maybe, is there a date? What do you reckon?
I don't know. It's a really difficult thing to do. So as Joanna mentioned, currently the state of the art in AI is kind of mimicking what humans do. It is not kind of real intelligence emerging from the machine. It's kind of giving it example about how human would think about something, and then the machine just replicates that. Like, no matter, like, I mean, the fact that we are calling that thought process intelligent is separate from, like, the machine to be able to do an intelligent thing by itself. So I think we are far from it. Like, given the current state of affairs, I don't know.
Okay, and a proper answer, because it's spoken like a true researcher. I've got a question from Nigel. I see AI projects that build their initial model and get promising results, but that have given no thought to how this model can be continuously improved or refined. This seems to be the old 80-20 rule, where 20% of the effort is needed for the initial model, and then 80% for developing a solution for ongoing improvement. Do you see something similar in the project you observe? I'm happy for anyone to take that.
Yeah, so let me chime in on this one, Bernadette, because I think Nigel's comment here is again related to what I was observing with companies starting to do a proof of concept, but then how do you keep it going? How do you get it into production? So I actually do agree on this sort of 80-20 rule, that getting something started is not where the bulk of the cost and expense and effort is going to be. Putting it into production, keeping it running, is where basically the heavy lifting goes on. And so I do view that a lot of the initial work is around building the initial model, but then how do I make that real? And so let me give a specific example of one of the recent things that I was working on right before I joined Monash, was around IT operations and using AI to improve the ability to manage IT operations within your data center. So doing a proof of concept that shows, for example, in the middle of an outage, an IT outage, I can use an AI agent to make it faster to get to problem resolution. That's a proof of concept. Getting it into production so that my AI agent, my AI virtual agent, is in essence my trusted site reliability engineer or my trusted operations manager that is there for me 24/7, who is constantly learning about all of the outages I may have had in the past. That requires investment in keeping your models up to date. It requires investment in keeping your data sets up to date and your training. And that's not build it once. You've got to continue to invest and keep the systems current. But it's this constant 24/7 view. And so the virtual agents are great if you want to keep your operations up and running 24/7, but you have to keep the data current, and you can't just build the model once and then run for a year. You've got to continue to invest to keep your models current. So I completely agree with this view of an 80-20 level of investment. The production heavy lifting is where the bulk of the investment costs are going to be.
Yeah, true. I've got a question from Jean again. Can Mr. Speaker in Parliament be replaced with a bot in the future? And will the bot be biased, though? So who would like to take that question?
I'll have a go at that. Well, look, I don't know about that use case specifically, but this question of bias is really pertinent, isn't it? It's a live issue, and we haven't quite resolved this. I think one thing that COVID has shown is the massive structural inequities in society, right? And the key for AI, obviously, going forward is that we need to iron out the bias. And you need to be alive to where bias is going to be entering. So it'll certainly be, obviously, the bulk of it will be in the data and the distribution of that data that you use to train your models on. But I would also take it a little bit further and say that, we need to be cognizant of the people who are actually involved in building our models. So up until now, a lot of data has been built by Google, by Facebook, by Amazon. You tended to have a lot of men in tech teams, for example. Going forward, I think it's really important that we have diverse teams, and that not just diversity at a superficial level like gender, for example, but that is important, right? I mean, incredibly important that we encourage women into the sector, but also diversity of thought, right? So we don't want to have everyone reinforcing everyone's groupthink. We need to have diverse voices, dissenting voices, in order to get the best outcomes. And we have to obviously be inclusive. So, it's incredibly important that developers engage with their end users and do so, I think, at a very early stage. Now, that's something I never did, and I think I'd never did it because I'm the provider, I'm the user of the product, and I'm one of the developers, right? So I just thought, oh well, I know what I'm doing. I've invested in this project for a long time. I don't need to talk to people. But of course, we did the study where we engaged with our end users at the Alfred, and we published this paper. Actually, it's on the website, and it's one of the best things I ever did. Honestly, we got 35 clinicians from nursing, radiology, hematology, infectious diseases, pharmacy, and respiratory medicine. And this is actually the team that looks after a patient who gets a fungal infection. It's never one person, right? In medicine, everything is delivered through teams. And by sitting down and talking to them in depth, we did a content analysis, and it was phenomenal to see what people said. And the learning that came from this is that I realized that, end users actually have all the problems will float to the top, but so do the solutions. They know how to fix the problem. You just have to ask them.
Yeah, good point. And this is from Nathan. Do you think, this is going to be a challenge, do you think neuromorphic computing could herald a new paradigm in AI? And if not, what are its limitations?
So most computer architectures today are based on a Van Neumann computer architecture. Neuromorphic computing is a style of, in essence, designing a different style of chip design, high I/O input-output characteristics to build the chip architecture modeled more on the neuron structure within the human brain, with a view that says, if I have a neuromorphic chip that is designed information-wise to exchange information like the synapses in the brain, what could it enable for me? So, for example, could I be much, much better at recognizing images and doing vision and visual video analytics if I had a neuromorphic chip design? So I think it's really relevant for visual acuity style of problem solving. I think it's a challenge to build a general purpose AI machine with a neuromorphic system.
Amazing, Joanna. You did that in 2 minutes. Incredible. I take my hat off to you. I take my hat off to everybody. What an amazing panel. Thank you. I'd just like to wrap up. So we finish on time by saying, with a quote from Malcolm X, which was, education is our passport to the future. For tomorrow belongs to the people who prepare for it today. And what you've seen are 3 amazing people who are preparing it for us today for the future. So, ladies and gentlemen, thank you for your participation, your passion, and for turning up today and for being part of this event. Now, we've been educated today by our incredible panel. I'm wondering if you could educate us a little bit about what future events you'd like to hear about and the topics and how you found today. So if you could please take a moment to fill in the survey that's going to be coming your way. And I'd just like to take this opportunity to thank the Monash team who do an amazing job in putting this all together. A big virtual round of applause for them. And just to thank our amazing panelists today, Joanna, Batstone, and Michelle Ananda-Rajah, and Reza Haffari. Thank you very much. Good afternoon and have a great day.